Welcome everyone in this new video on Figma. Today we'll get on with prototyping, first looking at a few settings we had left to analyze in the interaction panel. First we create again two unvoid large frames, and inside them we create two equal circles by clicking Alt, and we move one at the bottom of the frame and one at the top. So now we're going to look at the acceleration and deceleration of the transition movements from one frame to another. This section here, with the navigate to option here and with after delay mode. The first one option is linear. We apply it both to go from frame 1 to 2 and vice versa. In this animation, acceleration is 0 because we have a constant speed of motion. But since objects in nature rarely move at a constant speed, linear curves can seem robotic and even boring and ineffective. The second one is ease in, which we apply only to the first arrow, while to the second one we will always leave linear now on to better understand the movements, and we also increase the duration time of these animations from 300 milliseconds to 1200 milliseconds. Ease in therefore creates an animation that starts slowly and accelerates at the end of its duration, while ease out is the opposite of ease in, and therefore the animation starts fast and slows down at the end of its duration. Ease in and ease out logically starts at the animation slowly, speed up in the middle, and slow down at the end of its duration. We now move forward with ease in back, which instead causes the animation to overshoot the initial frame when the position we choose, and then speeds up towards the end. This creates a small bounce in the animation that acts as an anticipatory action, like a run-up of a ball. In contrast with ease up back, the animation starts fast, then slows down and overshoots the final keyframe value, and this creates a bounce in the animation that acts as a slower settling, in contrast to a run-up as we have seen before. Ease in and out back, on the other hand, precisely, is the union of the previous two. It starts the animation slowly, passing the value of the initial frame, then accelerates rapidly before slowing down and passing the value of the final frame. This creates an early bounce at the beginning, a fast motion, and a bounce motion before the final state. Let's move on to custom Bezier. That is, we have the ability to customize our animation through a graph, a Bezier curve editor, which always comes back in some way. If you want to get a little bit clear ideas of how curves work with their points and handles, I suggest you go and catch up if you haven't seen it, lesson 4, specifically about the pen tool. Well, with this very famous type of curve, we can also adjust the movements of our elements. Specifically, a cubic Bezier curve is defined by 4 points. These points are represented by the square perimeter of this graph. The axis of the graph represent time applied to the x-axis and position instead to the y-axis. These are two keyframes that indicate the initial and final state of the animation. These are set to 0.0, where start time and start position, here at the bottom left, and 1.1 at the opposite side, at the top right, that is the final position in the animation and the final time. Clicking on the bullets, then the keyframe, we will also present out the adjustable handles, which define the values of the curve itself. The more the curve represents an S, the slower the movement will be at the beginning and at the end, and faster in the middle. As you see from this section of the curve, in the middle, that is steeper, where the position, then the y-coordinates, increase, for example, by a lot in a very short x interval. You can reason in this way, so considering position and time, to create as many graphs as you want. And you can also extend the curve beyond the dashes perimeter of the graph, which is what the ease and out back present does. And at the end, to create an early bounce at the beginning or a bounce effect at the end of the animation. Alternatively, we can also use this field to enter numerical values ranging from 0 to 1 to define the position of the two handles. For example, we write 0.8, 0 and 0.2, 1. Be aware, though, that it is not possible to save a custom curve for future use. We could get the same effect if we can mark these values aside ourselves and then re-enter them for the next time. Now let's move on to the other 5 types of motion acceleration separated by this line here, because they are slightly different and in fact can be called spring animations. The first one is gentle, meaning that is the most neutral option of the spring curves. As you also see from the small preview here, it is actually an ease out back glider, in fact, a smaller setting on the final keyframe. The second item is quick, so the same as gentle in form but much faster. After we have bouncy, in which, as you see, there's not just one setting but it's multiple bounces, and it's of course a slightly more cartoony, exaggerated animation. Slow is simply a steady linear move. The last one, custom spring, allows us to again customize our movement with our spring curves. So that opens up to us a very particular graph in which we have represented these same values here, the values of stiffness, damping, and mass. Stiffness governs how soft the bounces are, or rather how wide, smooth the oscillations are, and so by dragging back and forth, we can decide how long our ball should take to make that particular number of bounces. Inevitably, if the time is short to make that many bounces, the movement will seem more abrupt and stiff, which is why we talk about stiffness. Damping, on the other hand, determines the progressive reduction of the amplitude of the oscillation over time. So the lower the number, the more similar the waves, we can call them, will be to each other, and therefore to get to the complete stop of our ball, it will take longer compared to a high value, which will cause the curves to decrease in amplitude much more rapidly toward the end of the line. The value 0 is not available because otherwise our spring would be active indefinitely without any damping. So the minimum value is 0.01. However, we try to put 1 and we still see how the curves are really still very similar one another, and we therefore see that our balls will move upward, always making slightly smaller bounces. If we increase the damping to a fairly higher value instead precisely, you see that we first have a larger curve, and then they quickly go smaller until they settle around a straight line. Damping and stiffness are related to each other, so changing the values of one inevitably changes the value of the other, while mass finally influences the animation speed and bounce height. You need to manually adjust the value in the mass field, so you cannot do it from the graph, which however represents the change of this value by increasing the time and force of the bounces to move that particular mass. Do you see between mass 1 and mass 20, for example, how it changes? As for the Bezier curve of no spring movements, you cannot save a custom curve for future use, but we can save values that create a movement that we like. Well, now that we've gone through all the acceleration and deceleration options, let's move on to actions, of which so far we've only seen navigate to, the one most commonly used by far, which allows us to move from one frame of a prototype to another. Change to, as you can see right now, is not selectable, and that is because its use is only for interactive components, so for moving from one variant to another in a set of components. If you remember in lesson number 8 about components, variants, and instances, we saw a preview of this prototyping between the button labeled play, and we used this very default change to option. In the meantime, let's move on to back, which instead allows you to return to the previous screen. It is perfect for simulating the back button in prototypes, of course, so it should be applied clearly not to the first screen or frame, but to the subsequent screens. Set variables and conditional, unfortunately, are not available for the free FIGMA plan. While scroll to, we'll also see this in depth in the next video. Overlink allows the user to be directed to an URL outside the prototype. So if, for example, we want to attach external links or dictionary resources that are not available in the main navigation, once this option is selected, we have to enter the URL that we will have previously copied from a website or something like this into the appropriate field. Now we have the three overlay items, that is panels, screen, and other things that pop up above a frame, a screen, so not changing frames as in navigate to. So I, for example, have prepared this very simple layout where I want from the menu item, upon clicking on it, a little panel with several clickable menu items pops up. To make this possible, I have to take in prototype mode my text and link it to my drop-down menu that I keep strictly out here and choose the Open Overlay item. First, we check that I've chosen the right frame, this one here, which we can also rename from here, I remember, to you. After that, we can choose between Instant Only, Fade In, or Move in modes. We choose Instant Now. Underneath, we have the settings, the further settings, and we can choose where in the larger main frame our menu will appear. We can choose between these, so center, left, top center, and so on, or we can choose to do it manually. And a slightly more transparent preview will appear that we can move to our linking and, for example, put it right below the writing. So we see that if with Shift Spacebar we open the preview and click on the menu, that what we wanted will happen. The very useful additional option here to check is Close when clicking out the panel itself, which eliminates the need to prototype the reverse action, the next one close overlay, unless we want a different way to close than just clicking out. Then perhaps schedule the use of an X on which to click to close an on-screen warning or a cooking acceptance button that then automatically close the request pane itself as well. And so in those two cases, the X and the button would be the hotspots from which the arrow with the close overlay interaction will start, which will have as its destination simply the main screen. Instead, let's go back here for a moment to this last option, Add Background, which allows you to add precisely a background to the main screen when the overlay is open, and it's often used, as we're suggested here, simply to add some dark underneath the light instead the frame that pops up above. If we really wanted each of these drop-down menu items to take us to another page, then all we would have to do is link it back to a new frame. We close this video with Swap Overlay, which precisely allows us to replace one frame with another. The behavior is similar to that of Navigate to option, but it will swap the current overlay with a new target frame. The new overlay will retain the same settings as the original one, but the use of the swap does not add the frame to the prototype history. So if you want the user to be able to use the back action to move between overlays, you may want to use the Navigate to option between them. Well, I would say that's it for today. Thank you for watching so far. If you liked the video, please leave a like and a comment for any doubt or suggestion. And if you want, you can also join as a supporter to help us create new contents. And we will see you in the next video.